Okay, this is Chapter 6, Section 3, Multiple Angle Equations. It's the last section we're going to cover in Chapter 6. I'm David Dipple from Lone Star College, Montgomery. Okay, suppose you have sine 2x, cosine 2x, sine x is equal to 1 over the square root of 2. Okay, sine, cosine, sine, that's an identity. So you can combine those. That's sine of adding the two angles together. So you get sine of 3x is 1 over the square root of 2. Now this 3 right here means I'm going to find my answers by going 3 times around the circle. So 3 times around the circle, where is sine square root of 2 over 2? That's at all the 45-degree angles at the top, first and second quadrant. Again, I'm going to go 3 times around the circle. So that's 1/4, 3/4. That's the first circle. If I keep counting around the circle, the next time it happens is 9 and 11. And the next time it happens should be 17 and 19. So that is 3 times around the circle. Then you divide everything by 3, and I reduced the fractions. It will reduce. So it's pi divided by 12. 3 canceled, so it's pi over 4. 9 canceled, so I get 3 pi over 4. 11 doesn't, so it's pi over 11. Actually, 11 pi over 12. 17 pi over 12, and 19 pi over 12. Again, the trick is if there's a 3 here, 3 times around the circle. If there is a 2, twice around the circle. The coefficient of our x tells us how many times around the circle to go, because after you do that, you'll notice 19 pi over 12 is still only one circle of our final answers. If you don't do that, you leave out a bunch of answers. Okay, another example. Suppose you have tan squared 2x is equal to 1. Well, 2 means twice around the circle. Okay, we move the square by taking the square root and getting plus or minus. So tangent is plus or minus 1. And again, 2 means twice around the circle. Now tangent is 1 in the first and third quadrant, and it's -1 in the second and fourth. So we write all those angles together. Again, we're in radians. And we're going to go twice around the circle. So it's 1/4, 3, 5, and 7/4. That's the first time around the circle. Then if you keep going, it'll be 9, 11, 13, and 15. So if you count around a circle 2 times around, those are all the places that you're going to get the number 1 for tangent. Now divide all those by 2. Nothing reduces. So you get x is pi over 8, 3 pi over 8, 5, 7, 9, 11, 13, and 15 pi over 8. And again, if you look at these, our final answers are just in a single circle for the answers. So the big trick on these is anytime there's a multiple angle here, that tells you how many times around the circle you have to go to get your initial answers. Then you divide to get your final answers. All right, the last problem is kind of a trick. Sine minus cosine is equal to 1. There's a lot of different ways to do this. One is to just square both sides. So you have sine minus cosine squared is equal to 1 squared. And then you square out the binomial, so you get squared the sine, multiply them and double it, so it's -2 sine cosine, plus cosine squared is equal to 1. Now, cosine squared plus sine squared is 1, and 2 sine cosine is the double angle formula. Okay, so we have sine squared plus cosine squared turns into 1, and then again, this 2 sine cosine is the double angle formula, so we have this is sine 2 theta, and these ones subtract out and you get 0, so you can divide by the negative. So you have sine 2 theta is equal to 0. That's twice around the circle. Well, actually, this one is, there's no restrictions, 0 to 2 pi, or in degrees. I wrote the angles out in degrees, but they keep going forever. So we have 0, 180, 360, 540, keep going. Divide everything by 2, and you get 0, 90, etc., etc., etc. And those are going to be multiples of 90. So it's 0 degrees plus 90 times some number. You can call it k, or you can call it n. Just pick a variable. So those are all the ways to solve multiple angle equations.